Hello everyone, happy to see you here. Welcome back to my channel Higher Mathematics. Today we have a very interesting question from Math Olympiad. X squared minus x cubed equal to 12. We need to solve this question for x. So if you have your solution, your answer, you can write it in the comments below and then we will check our answer. So it will be really interesting. So first of all, I want to write this 12 on the left side. Of course with the negative sign, yeah? So let's do it. So we have x squared minus x cubed minus 12 and equal to 0. What I'm going to do next? Secondly, let's express this 12 as a sum 8 plus 4. And a lot of students might be asking, Mister, why do you choose 8 plus 4? But just look at it. So we have 12. I'm going to express this 12 as 8 plus 4. So let's do it right now. As a result, what do we have? X squared minus x cubed minus, instead of 12, we write 8 plus 4. So 8 plus 4 and equal to 0. Right now, let's open our parentheses real quick. Let's do it. So we have x squared minus x cubed minus 8 and minus 4. And right now, here's a quick explanation why 8 and 4 are great constant for us. Because to be honest, we can express it in a different way. We can write it as 6 plus 6. We can express it as 7 plus 5. But why this expression is the best for us? So I'm talking about 8 plus 4. This 8 can be written as 2 cubed. Let's do it right now. So we have x squared minus x cubed minus, instead of 8, we write 2 cubed. So we have 2 cubed. And instead of this 4, we write 2 square. So minus 2 square. And right now, I hope you see this, that we have, in terms of like variables, we have x squared, so we have a square, and we have right here a square. So we can easily group it. And we have the same thing with x cubed and 2 cubed. So we have two expressions with the third power. So I'm gonna underline it as well, but with different line. And right now, let's group our squares and our cubes. Let's do it. Let's see what will happen. So first of all, I want to group our squares. So x squared minus 2 squared. So we have x squared minus 2 squared. This is our first step. And the next step, we have minus. And right here, we have x cubed, but plus 2 cubed, because we have parentheses. So we have x cubed plus 2 cube and equal to 0. And right now, let's look at this question from a different angle, because if we look closely, right here we have difference of squares in these parentheses. Right here we have a sum of 2 cubes, and we really need to know about these two formulas. Extremely important, maybe the one that's like the most popular formula nowadays. Difference of squares when we have x squared minus y squared. So when we have this formula, we can express this, we can write it as x plus y, so x plus y, and x minus y, Really great. And right now, the second formula, we have x cubed minus or plus, we have right here in our question, we have plus, so we have x cubed plus y cubed. As a result, what do we have? We have x plus y, so according to our formula, so we have x plus y, and we're going to multiply it by x squared minus xy. This is our table case. Don't be scared about it. This is table case. You can easily fit this question in your book, in your algebra book. Don't be scared about this. Basic school basic cases. Yeah, we have the first one, difference of squares and sum of 2 cubes. And right now, extremely great moment, because we can apply this formula to these parentheses and this sum of cubes to this parentheses. And let's do this right now. I'm going to start on the left side right here. So first of all, what we're going to do, difference of squares. So we have x plus 2, x minus 2, x plus 2, x minus 2. Yeah, we split it. We express this in terms of first formula. And the second formula, so we have minus. What do we have? X plus 2. And in the second parenthesis, we have x squared minus 2x and plus 2 squared, so plus 4 equal to 0. Really great. And right now, once more, let's look from a different angle. So we apply these both formulas, but here's the question, why do we apply these both formulas? Because right now, we can think we have x plus 2 right here, and we have x plus 2 right here, so we can easily factor it as a common. So let's do it right now. So we have x plus 2 right here, we factor it, x plus 2, and in the second parenthesis right here, what do we have? X minus 2, or here we have x minus 2, so I hope you get it. So here we have minus 2, doesn't matter, yeah? So when we factor it, we have x minus 2 from this part, so we have x minus 2 from this part, and from here we have minus these parentheses from here. So as a result, we can easily change all these signs, because we have a negative sign before this parentheses. So as a result, let's don't skip, okay? So as a result, minus x squared minus 2x, because maybe a lot of students watch my video, so let's write it like that. And right now in the second step, we need to change all these signs because maybe a lot of students get confused when I do this, when I did it. So right now, let's write the next step. So we have x plus 2 right here. And what do we have? X minus 2, the same beginning, but right here, let's change all the signs. So we have minus x squared plus 2x and minus 4 equal to 0. Right now, let's find the common things. We have minus x squared. We're going to write it on the first position. So let's do it. So we have x plus 2, and in the second parenthesis, what do we have? Minus x squared on the first position, minus x squared. What about x? X plus 2x, we have 3x, so plus 3x. Plus 3x, and we have right here minus 2 minus 4, we have minus 6, so minus 6 is equal to 0. Right now, let's multiply both sides by minus 1. Okay, let's do it right now because we have a negative sign right here, so we don't need it. We need a classic case with a classic coefficients, so we multiply it by minus 1. And that's why we have x plus 2 in the beginning without any changes. But this one, we're going to change all the sign because of this negative. Okay, so x squared minus 3x and plus 6 equal to 0. So I really hope you understand. This part. So what we're going to do next? Of course, a product equal to 0 when the first parenthesis equal to 0. So from here we have that x plus 2 is equal to 0. Or the second parenthesis is equal to 0, or x squared minus 3x plus 6 is equal to 0. Okay, really great. So we have two equations. We can easily solve this one real quick. So we have x first equal to minus 2 from here, yeah? X first equal to minus 2. And from here we have a quadratic equation. Of course, this is up to you how you prefer solving this question. I prefer solving this question with the basic method of coefficients. So we have a equal to 1, b equal to minus 3, and c equal to 6. So right now let's find real quick a discriminant. Of course, this is up to you. How do you prefer solving this question? So discriminant equal to b squared minus 4ac. From here, what do we have? B squared, so minus 3 squared minus 4 times 1 times 6, yeah? So our discriminant is equal to, so our d is equal to, we have 9 minus 24, yeah? So we have 9 minus 24. So our discriminant is equal to minus 15. So it means that in this branch we have like two complex roots, okay? Because discriminant is negative, so it means that in this branch, exactly in this branch, we will have two complex roots. So let's find it. So as a result, we have x second and third equal to minus b, all known formula, yeah? Plus minus square root of d and all over 2a. So as a result, we have minus b minus 3 plus minus square root of discriminant square root of minus 15 and all over 2 times 1. Let's simplify this real quick because yeah, we can do it. We have two negative signs. We can write it as a positive. So we have 3 plus minus square root of minus 15. How can we split it? Or do we need to like split this expression? I suggest you to split it, but not like 3 times 5 times minus 1. We can split it like square root of minus 1, something like that, and times square root of 15, because 15 is not a good number, not a good value in terms of like how can we express it, like with the square root, or can we get square root from here? We can't get it because we have 3 times 5, so both values are not good in terms of square root, so we can't get a square root from here. So let's leave it like that. So square root of 15 and all over 2. Right now, what do we have here? We have 3 plus minus square root of minus 1 equal to I, and square root of 15, we'll leave it like that. So we have I square root of 15 over 2. And of course, right here we have something like that. And I suggest you to divide both sides, so both values, 3 and I square root of 15. Let's divide this numerator by 2. So we have 3 halves, so we can easily split it like real part. So right here we have real part, and we can easily write plus minus I square root of 15 over 2. We have the same but imaginary part. This is up to you how you teach this thing in school. This is also up to you and up to your teacher. How do you prefer writing your final answer? Because this is like we split it in terms of real and imaginary part. Of course, this is also an answer, but this is up to you. So let's write our final answer. So I'm going to continue right here. So our answer, and let's write x second with the positive sign, for example, 3 half plus I square root of 15 over 2, and of course x third equal to 3 half minus I square root of 15 over 2. And the final, in the end, in conclusion, I'm gonna check real quick our x first equal to minus 2. So let's check real quick. And what do we had in the beginning? We had x squared minus x cubed equal to 12. So let's check it real quick. First of all, for x equal to minus 1, let's check only this one. So we have minus 2 square minus 2 cube equal to 12. Okay, this is 3. Okay, I hope you get it. So right now minus 2 square equal to 4, minus 2 cube, so the sign, the final sign will be negative because we have an odd power, so this negative and this one is equal to plus, and 2 cube equal to 8. So as a result we have a correct expression, so our root is great for us. This one is real number root, and these two roots are complex root. And few thoughts about this question, because maybe a lot of students might be thinking there's like a third, a fourth root especially, yeah. And here's my quick thoughts, here's my quick explanation why can't we get the fourth root from here. According to a fundamental theorem of algebra, you can easily see this question right here. I recommend you every time, it doesn't matter what equation do you have, like 6 power 7, power 8, a square, like a quadratic equation, every time just use this fundamental theorem of algebra in your head. Okay, so what I mean, like fundamental theorem of algebra, this theorem help us to like consider how many roots we get from this equation. So for example, in this equation, x squared minus x cubed equal to 12. Yeah, and what does it mean, the fundamental theorem of algebra? First of all, the first step, you can easily do it in like 3 or 4 seconds. First of all, you need to scan what is the highest power in your question. So, for example, exactly in this case, the highest power, I hope you see this, that the highest power is 3. So it means that in general, basically, yeah, we have 3 roots in total. We don't know how many real number roots, we don't know how many complex roots, but we have 3 roots in total, and here's like a quick proof that we solved this question correctly. We have 3 roots, and we can't get the 4th root, because according to the theorem, third power, it means 3 roots. And for example, right here I have enough space. For example, we have this equation, x to the 6, for example, minus 4 equal to 0, something like that. And a lot of students might be thinking, okay, this expression we write on the right side, so we have x to the 6 equal to 4 and something like x equal to like plus minus 6 root of 4, something like that, and they say okay, 2 roots right here, but this is not a full solution. Every time you have an equation, you need to scan what is the highest power. Okay, x to the 6th power, it means okay, I have 6 roots right here. This is the maximum amount of roots, so 6 roots. I don't know how many real number roots, I don't know how many complex roots, but basically like in general, I have 6 roots, maybe 2 complex, 3 real, or 3 real, 3 complex. You know, this combination, this is like, it depends on equation you have, okay? But basically, the highest power, the maximum power, means how many roots you can get from here. And in my case, everything is great because the third power is the highest one, the maximum amount of roots is 3, and I have exactly the same answer with 3 roots, 1 real and 2 complex. So I really hope you understand my solution. Once more, you can see this solution real quick, not that hard, but with different tricky moments. So I hope you understand it. Write your thoughts, try to respond in the comments below. Let's discuss a little bit about this question. It's also really great to do it in the comments below. So thank you for your time, take care of yourself, and have a great day. See you in the next videos.